Imagine this. You're drifting through the vast, inky blackness of space, stars twinkling like distant fireflies, when suddenly, a blinding beacon erupts before you. It's not a star, not a supernova, but something far stranger, a white hole. Unlike the ravenous black holes you've heard about, this cosmic enigma doesn't swallow. It spews. Light, matter, everything bursts out, as if the universe itself is exhaling. You're staring at the opposite of a black hole, a theoretical twin that defies everything you thought you knew about the cosmos. But what exactly is a white hole, and could it really exist? Buckle up, because we're diving into one of the universe's wildest mysteries. And before we go deeper, hit pause for a second. What do you think a white hole could be? Drop your thoughts in the comments, and let's unravel this cosmic puzzle together. Let's start with the basics. You've probably heard of black holes. Those gravitational monsters so dense that not even light can escape their grip. They're the ultimate cosmic vacuum cleaners, sucking in stars, gas, and even time itself. But a white hole? It's the flip side of that coin. Picture a black hole as a one-way street into oblivion. Now imagine a white hole as a one-way street out of oblivion. Nothing can enter it. Not you, not a spaceship, not even a stray photon. Instead, it's like a cosmic fountain, relentlessly pushing matter and light outward. The idea sounds like something ripped from a sci-fi novel, but it's rooted in the hard math of Einstein's general relativity. Yes, the same equations that predict black holes also allow for their opposites, white holes. Now, you might be wondering, why haven't we seen one of these glowing cosmic geysers? That's where things get tricky. White holes are theoretical constructs, born from the elegant symmetry of Einstein's equations. In the 1960s, physicists like Igor Novikov started playing with these ideas, suggesting white holes could be the exit points of black holes. It's like imagining a cosmic recycling system. What goes into a black hole might come out of a white hole somewhere, or somewhen else. But here's the kicker. No one's ever observed a white hole. They're like the unicorns of astrophysics, beautiful in theory, but elusive in reality. Still, their possibility keeps scientists up at night, wondering if they're missing something profound. Let's paint a picture. You're floating near a white hole, your spaceship bathed in its radiant glow. Unlike the eerie darkness of a black hole's event horizon, this boundary pulses with energy. Light streams toward you, not in a gentle wave, but with the force of a fire hose. You try to steer closer, but an invisible wall pushes you back. It's not gravity pulling you in. It's the opposite. A relentless repulsion. Your sensors go wild, detecting particles and radiation pouring out in a chaotic symphony. It's overwhelming, almost blinding, like staring into the universe's most intense spotlight. And yet, there's something oddly familiar about it. This outpouring of light and matter feels like creation itself, a reverse echo of the Big Bang. Speaking of the Big Bang, here's a fun historical tidbit. When Einstein first published his theory of general relativity in 1915, he had no idea it would spawn ideas as wild as white holes. His equations were so groundbreaking that they predicted phenomena scientists wouldn't fully grasp for decades. Black holes were already mind-bending, but white holes? They're the kind of thing that makes you wonder if the universe is playing a cosmic prank. And here's a quirky fact to chew on. Some physicists speculate that white holes could be so unstable they'd collapse into black holes almost instantly. Imagine a cosmic pop-up that vanishes before you can snap a selfie with it. Now, let's get a bit modern. Today's astrophysicists are obsessed with symmetry in nature. Black holes and white holes feel like two sides of a cosmic yin-yang, balancing creation and destruction. But here's where it gets juicy. Some researchers argue white holes might not just be theoretical. Could they be hiding in plain sight, masquerading as other cosmic phenomena? Maybe a distant gamma-ray burst or a peculiar quasar is actually a white hole in disguise. It's a tantalizing debate, one that splits the scientific community. On one side, you've got the skeptics who say white holes are just mathematical curiosities, artifacts of equations that don't exist in the real universe. On the other, you've got the dreamers who think they could unlock secrets about the origins of everything. Let's lean into that sensory experience again. Picture yourself back at that white hole's edge. The light isn't just bright, it's disorienting. A kaleidoscope of colors and energies that make your head spin. You feel like you're witnessing the birth of a star, or maybe something even grander. Your heart races as you realize this could be a window to another time, another universe. The sheer power of it humbles you, reminding you how small you are in the grand scheme. And yet, there's a thrill in that smallness, a spark of wonder that makes you want to know more. Why does this thing exist? What's fueling its relentless output? Is it a portal, a cosmic exhaust pipe, or something we can't yet fathom? Here's a playful thought to lighten the mood. If black holes are the universe's ultimate hoarders, collecting everything in sight, then white holes are the universe's most generous philanthropists, giving away light and matter like there's no tomorrow. But joking aside, the concept of white holes challenges us to rethink the universe's rules. If black holes represent the end of things, stars collapsing, matter vanishing, then white holes might represent beginnings. Could they be the seeds of new galaxies, new realities? It's the kind of question that keeps you staring at the stars, wondering what else is out there. Before we move on, let's circle back to that call to action. The idea of a white hole is so bizarre, so counterintuitive, that it demands your curiosity. Could these things really exist? Or are they just the universe's way of teasing us with possibilities? Pause this video, jump into the comments, and tell us, do you think white holes are out there, waiting to be found? Or are they just a physicist's pipe dream? Your thoughts might spark the next big idea in cosmology. And here's one last thing to ponder. White holes aren't just about physics. They're about imagination. They push us to question the boundaries of what's possible. In a universe where black holes were once thought impossible, who's to say white holes won't one day reveal themselves? For now, they remain a tantalizing mystery, a reminder that the cosmos is full of surprises. So, let's keep exploring, because the truth about white holes might just rewrite everything we know about the universe. You're floating in the void, the universe stretching endlessly around you, a tapestry of stars and nebulae shimmering in the distance. Suddenly you feel it, a tug, subtle at first, then relentless. Your spaceship lurches toward a point of absolute darkness, a void so profound it seems to erase the stars behind it. This is a black hole, the ultimate cosmic predator, devouring everything in its path, even light itself. But to understand the enigma of white holes, you first need to grasp what makes black holes tick. If white holes are the universe's great givers, black holes are its takers, and their mechanics hold the key to unraveling the mystery. So, let's dive into the heart of a black hole. Figuratively, of course, because nothing comes back from that trip. Picture a black hole as a cosmic whirlpool. At its center lies the singularity, a point of infinite density where space and time break down. Surrounding it is the event horizon, an invisible boundary marking the point of no return. Cross that line, and you're gone. No message, no signal, not even a cosmic postcard can escape. The gravity here is so intense that it warps reality itself, bending light and stretching time like taffy. You might think of gravity as a gentle force keeping you grounded on Earth. But near a black hole, it's a merciless beast, pulling in gas, dust, stars, and anything else foolish enough to wander too close. Let's set the scene. You're hovering just outside the event horizon, your heart pounding as you watch a distant star's light distort into a glowing ring around the black hole's silhouette. This is the accretion disk, a swirling maelstrom of superheated matter spiraling inward, glowing with ferocious energy before it vanishes. The disk hums with X-rays, a cosmic scream of matter being torn apart. It's both beautiful and terrifying, like watching a star perform its final dance before oblivion. Your sensors flicker, struggling to process the sheer chaos. You feel small, insignificant, yet utterly captivated by the raw power before you. Now, here's a historical gem. Black holes weren't always taken seriously. In the early 20th century, when Carl Schwarzschild solved Einstein's equations in 1916, he found solutions suggesting objects so dense they could trap light. Scientists dismissed them as mathematical oddities. Surely, nature wouldn't allow such monstrosities. But by the 1970s, evidence like X-ray emissions from binary star systems proved black holes were real. It's a reminder that the universe often laughs at our skepticism, delivering truths wilder than our wildest dreams. And here's a quirky fact to tickle your brain. Black holes can sing. When they merge, they ripple space-time, producing gravitational waves that we've detected with instruments like LIGO. Imagine two black holes colliding, their gravitational song echoing across billions of light years, like a cosmic duet played on the strings of the universe. It's the kind of thing that makes you want to high-five a physicist. Let's get modern for a moment. Today, black holes are superstars of astrophysics, thanks to breakthroughs like the Event Horizon Telescope, which in 2019 gave us the first ever image of a black hole's shadow, a blurry, glowing donut that captivated the world. Social media exploded with memes comparing it to everything from a cosmic bagel to the Eye of Sauron. But beyond the memes, that image was a triumph, proof that we can glimpse the unseeable. It also deepened the mystery of white holes. If black holes are so real, so tangible, could their opposites be out there, hiding in the cosmic shadows? Now, let's talk mechanics. A black hole forms when a massive star runs out of fuel and collapses under its own gravity, squeezing its core into a singularity. Smaller black holes can form from neutron-star collisions, while supermassive ones, millions or billions of times the sun's mass, lurk at the hearts of galaxies like our Milky Way. These giants shape their surroundings, orchestrating the dance of stars and gas clouds. But here's where it connects to white holes. Black holes don't just destroy, they transform. Some theories suggest that what goes into a black hole might not be lost forever. Could it emerge elsewhere, through a white hole? It's a debate that splits physicists down the middle. Some argue the information swallowed by a black hole is destroyed. Others say it's preserved, perhaps spat out in another form or place. Let's lean into the sensory again. Imagine you're closer now, just beyond the event horizon. The pull is stronger, your spaceship creaking under the strain. Time feels strange. Your clock ticks slower than one far away, a quirk of relativity called time dilation. If you could glance back at the universe, you'd see stars aging rapidly, their light red shifted into eerie hues. It's disorienting, like being caught in a dream where reality unravels. You're not just witnessing a black hole, you're feeling its grip on the fabric of existence. And yet, there's a thrill in it, a rush of knowing you're brushing against one of the universe's deepest secrets. Here's a light-hearted jab to break the tension. If black holes were cosmic chefs, their recipe would be simple. Take everything, blend it into nothingness, and serve it with a side of mystery. But seriously, black holes challenge our understanding of physics. They're where gravity meets quantum mechanics, and the rules start to fray. One of the hottest debates in science today is the information paradox. Quantum theory says information can't be destroyed. But black holes seem to gobble it up. Some physicists, like Stephen Hawking, propose that black holes might leak information through radiation, a process now called Hawking radiation. It's faint, almost imperceptible, but it hints that black holes aren't the end of the story. This brings us closer to white holes. If black holes take in matter and light, could white holes be their counterparts, releasing what was lost? The idea is seductive, like finding the missing half of a cosmic puzzle. But to explore that, we need to understand the machinery of black holes fully. Their event horizons aren't just boundaries. They're gateways to questions about time, space, and reality. Could a black hole's singularity connect to a white hole's outburst? It's a tantalizing possibility, one that makes you wonder if the universe is more interconnected than we ever imagined. Before we wrap up, let's revisit that call to action from earlier. Black holes are real, proven, and mind-boggling, but white holes remain a mystery. What do you think? Could the stuff swallowed by a black hole be reborn through a white hole somewhere else? Jump into the comments and share your wildest theories. The universe is full of surprises, and your ideas might spark the next big breakthrough. In the end, black holes are more than cosmic vacuum cleaners. They're windows into the universe's deepest mechanics. They set the stage for understanding white holes, those hypothetical opposites that might hold the key to creation itself. So, as we pull away from this dark abyss, keep your eyes peeled for what comes next. The universe has more secrets to share, and we're just getting started. You're standing at the edge of imagination, staring into a universe where the impossible feels tantalizingly close. The stars around you glitter like distant promises, but your attention is locked on a radiant anomaly, a white hole blazing with light and matter, pushing everything away. Unlike the black holes you've come to know, this cosmic oddity doesn't devour. It creates, spewing out light and particles as if birthing new realities. But here's the catch. White holes might only exist in the elegant equations of physics, not in the real cosmos. To understand why, you need to dive into the theoretical roots of these mysterious objects. Are white holes a cosmic reality or just a mathematician's fever dream? Let's find out. Picture yourself in a physicist's study, surrounded by chalkboards covered in cryptic symbols. Einstein's field equations sprawling like a cosmic code. These equations, the backbone of general relativity, describe how gravity shapes space and time. When you solve them for a collapsing star, you get a black hole. But flip the math, reverse the flow of time, and something wild emerges. A white hole. It's a solution that's mathematically valid, predicting an object where nothing can enter, only exit. Light, matter, even information pour out, defying the pull of gravity. It's like a black hole running backward, a cosmic exhale where everything escapes an invisible barrier called the event horizon. Let's set the scene. You're drifting near this theoretical white hole, your spaceship bathed in a torrent of radiant energy. The light isn't just bright, it's relentless. A flood of photons and particles rushing past you like a river breaking free from a dam. Your instruments scream with data, overwhelmed by the sheer volume of matter streaming outward. It's chaotic, yet mesmerizing, like watching a star being born in fast forward. You try to move closer, but an unseen force repels you, as if the universe itself is saying, "No entry." The sensation is humbling, a reminder that some things in the cosmos are beyond your reach, no matter how advanced your tech. Here's a historical anchor. When Einstein published his theory of general relativity in 1915, it was a revolution. Scientists like Carl Schwarzschild used his equations to predict black holes, but white holes emerged as a curious byproduct. In the 1960s, Soviet physicist Igor Novikov took it further, suggesting white holes could be the other end of black holes, connected across time or space. It was a bold idea, born from the same math that reshaped our understanding of gravity. Yet, unlike black holes, which we've confirmed with telescopes and gravitational waves, white holes remain stubbornly theoretical. No one's ever seen one. Now for a quirky twist. Some physicists have speculated that white holes might be so unstable they'd vanish almost instantly after forming. Imagine a cosmic firework that explodes into existence, showers the universe with light, then collapses into a black hole faster than you can blink. It's like the universe's shortest-lived party trick. Here one moment, gone the next. This instability makes white holes even harder to pin down, adding to their mystique. Let's bring it into the modern day. Today's physicists are hooked on the symmetry of Einstein's equations. Black holes and white holes feel like cosmic twins. One takes, one gives. But the debate rages. Are white holes physically possible, or are they just artifacts of math? Some argue they could exist in exotic conditions, like the early universe or in higher dimensions. Others say they violate thermodynamics, particularly the second law, which says entropy must increase. A white hole spitting out ordered matter seems to defy that rule, creating a cosmic conundrum. Could they exist briefly, perhaps as remnants of primordial events? It's a question that keeps theorists up at night, scribbling equations and chasing possibilities. Back to the sensory experience. You're still near that white hole. The light's so intense it feels like it's rewriting your reality. Colors shift. Blues, whites, and golds blending into a dazzling cascade. The energy hums, a low vibration you feel in your chest, like the universe is singing a song only you can hear. There's a thrill in the chaos, a sense that you're witnessing something forbidden, something the cosmos hasn't fully revealed. Your mind races with questions. Where is all this matter coming from? Is it new, or is it recycled from somewhere else? Maybe a black hole in another time or place? Here's a playful nudge to lighten the mood. If black holes are the universe's ultimate hoarders, white holes are like that friend who can't stop giving away their stuff during a spring cleaning frenzy. But jokes aside, the theory of white holes pushes us to rethink reality. They're not just opposites of black holes. They challenge our understanding of time itself. In a black hole, time slows as you approach the event horizon, stretching toward infinity. In a white hole, time might work backward, with matter emerging from a singularity as if it's being born anew. It's a mind-bending idea, one that makes you feel like you're teetering on the edge of a cosmic paradox. The academic debate here is fierce. Some physicists, like Carlo Rovelli, suggest white holes could be linked to quantum effects, perhaps forming briefly during black hole evaporation via Hawking radiation. Others argue they're impossible in our universe's current state, confined to the realm of pure theory. Could a white hole exist in a different universe with different physical laws? Or are they relics of the Big Bang, long since vanished? These questions spark heated discussions in lecture halls and online forums, with no clear answers yet. Let's circle back to that cosmic scene. You're still out there, watching the white hole's radiant outburst. It feels alive, almost defiant, as if it's daring you to understand its secrets. Your spaceship trembles under the onslaught of particles, and you can't help but feel a mix of awe and frustration. This thing is so close, yet so untouchable. It's a reminder of how much we still don't know about the universe, how many mysteries lie just beyond our grasp. And yet, that mystery fuels your curiosity, urging you to keep exploring, to keep asking questions. Before we move on, let's revisit that call to action. White holes are a puzzle wrapped in a mystery. Do you think they could exist, maybe as fleeting cosmic events or hidden in plain sight? Pause the video, jump into the comments, and share your thoughts. Could white holes be the key to unlocking the universe's deepest secrets? Or are they just a beautiful idea? Your perspective might inspire someone else to look at the stars differently. In the end, white holes are a testament to the power of human imagination. They emerged from the same equations that gave us black holes. Yet they remain elusive, teasing us with possibilities. As we pull away from this radiant enigma, one thing is clear. The universe loves to keep us guessing. So, let's keep chasing those answers, because the truth about white holes might just change everything. You're suspended in the vastness of space, the stars around you mere pinpricks against the infinite dark. Suddenly, you sense a pull, not toward a black hole's crushing void, but toward something stranger. A white hole blazes in the distance, spewing light and matter like a cosmic geyser. But here's the twist. What if this radiant outburst is connected to a black hole, not just across space, but across time itself? The idea sounds like it belongs in a sci-fi blockbuster, but it's rooted in one of the wildest concepts in physics. The Einstein-Rosen bridge, a theoretical tunnel linking a black hole's insatiable maw to a white hole's relentless outpour. Buckle up, because we're about to explore whether these cosmic opposites are two sides of the same mind-bending coin. Imagine a black hole as a cosmic drain, sucking in everything, stars, gas, even light, into its singularity, a point where physics, as you know it, collapses. Now picture a white hole, its mirror image, spitting out light and matter from a similar singularity, an untouchable fountain that nothing can enter. What if these two are connected? The theory goes that a black hole's singularity might link to a white hole's through a wormhole, a shortcut through space-time called an Einstein-Rosen bridge. You've seen wormholes in movies, portals zapping spaceships across galaxies. But in reality, they're far stranger, potentially tying together not just distant places, but different times or even universes. Let's paint the scene. You're hovering near a black hole, its event horizon a dark veil swallowing the stars behind it. Your heart races as you feel the tug of gravity, time itself slowing as you edge closer. Now, imagine a sudden shift. A tunnel of shimmering light opens, pulling you through a kaleidoscope of warped space. You emerge on the other side, blinded by a white hole's radiant flood. Light and particles rush past you, a torrent of creation that feels like the universe is being born again. The sensation is dizzying, like riding a roller coaster through the fabric of reality. You're not just traveling through space, you're surfing time itself. Here's a historical anchor. In 1935, Albert Einstein and Nathan Rosen published a paper exploring solutions to general relativity that described these bridges through space-time. They weren't thinking about sci-fi adventures, but about mathematical possibilities. Their work suggested that black holes could connect to other regions of space-time, or even other universes, via these tunnels. It was a radical idea, one that took decades to gain traction. Today, we call these connections wormholes, and they're a staple of theoretical physics. even if we've never seen one. Now for a quirky detail. Some physicists speculate that if you tried to cross an Einstein-Rosen bridge, you'd be torn apart by extreme tidal forces or crushed by the wormhole's instability. It's like the universe put up a "Do Not Enter" sign, complete with a cosmic shredder for anyone who ignores it. This instability makes wormholes and their white hole endpoints tricky to study, let alone visit. Yet, the idea persists, fueled by the tantalizing possibility that black holes and white holes are more than opposites. They're partners in a cosmic dance. Let's bring it into the modern day. The concept of wormholes has captured the imagination of everyone from physicists to Hollywood directors. Movies like Interstellar leaned heavily on the idea, with advisors like Kip Thorne ensuring the science wasn't too far-fetched. On social media, you'll find fans debating whether wormholes could be portals to parallel universes or time machines. But in labs, the debate is more grounded. Physicists argue over whether wormholes are stable enough to exist, even for a fleeting moment. Some suggest quantum effects, like negative energy, could prop open a wormhole long enough for something to pass through. Others say the math is seductive, but doesn't match reality. Wormholes might collapse faster than you can say, time travel. Back to the sensory experience. You're caught between these two cosmic giants. On one side, the black hole's gravity pulls at you, stretching your ship like a rubber band. On the other, the white hole's radiance pushes back, bathing you in a flood of light that feels almost alive. The wormhole between them hums, a low vibration that resonates in your bones. It's disorienting, exhilarating, like standing at the edge of a cliff between two realities. You can't help but wonder, if you could survive the journey, where or when would you end up? The past? The future? A universe where the laws of physics are wildly different? Here's a playful jab to lighten the mood. If black holes are the universe's ultimate vacuum cleaners, white holes are like overzealous party cannons, blasting confetti everywhere. But the idea of them being connected flips everything upside down. If a black hole swallows matter in one place, could a white hole spit it out somewhere else, or somewhen else? This is where the academic debate heats up. Some physicists argue that white holes could be the exit points of black holes, preserving the information that seems lost in the black hole's grip. A solution to the famous information paradox. Others counter that wormholes are too unstable, and white holes might only exist in the early universe or in mathematical models, not in the cosmos we observe. Let's dive deeper into that debate. The information paradox asks, what happens to the information about particles that fall into a black hole? Quantum mechanics says information can't be destroyed, but black holes seem to erase it. One radical idea is that a white hole on the other side of a wormhole could release that information like a cosmic recycling bin. But there's a catch. Wormholes might require exotic matter with negative mass to stay open, something we've never seen. It's a puzzle that keeps theorists arguing over coffee and equations, with no consensus in sight. Could a white hole be a time-reversed black hole, existing in the past? Or is it a portal to another universe entirely? Back to that cosmic scene. You're still there, caught in the tension between the black hole's pull and the white hole's push. The wormhole's glow pulses, each flash a reminder of the universe's mysteries. Your mind races with possibilities. Is this a bridge to another time, another reality? The thought is thrilling but terrifying. You're a speck in a cosmic machine that doesn't care about your existence. Yet that insignificance fuels your curiosity, urging you to keep exploring, to chase answers to questions we've only begun to ask. Let's revisit that call to action. The idea of a black hole and white hole connected across time or space is mind-blowing. What do you think? Could wormholes link these cosmic opposites? Or is it all just theoretical daydreaming? Pause the video, hit the comments, and share your wildest ideas. Your thoughts might spark a new perspective on this cosmic mystery. In the end, the connection between black holes and white holes challenges everything we know about time and space. Whether they're linked by wormholes or not, the possibility reminds us that the universe is a place of infinite wonder, where every answer leads to a dozen new questions. So, as we drift away from this cosmic bridge, let's keep our eyes on the stars and our minds open to the impossible. You're standing at the edge of everything, the universe sprawling before you like an endless canvas of stars and galaxies. But what if the entire cosmos, every star, every planet, every breath you take, began not with a bang, but with a white hole? The idea sounds like it belongs in a cosmic fairy tale. Yet some physicists dare to suggest that the Big Bang itself, the moment that birthed our universe, could have been the ultimate white hole, spewing out the raw materials of existence. It's a mind-bending hypothesis, one that ties the origin of everything to the mysterious counterpart of a black hole. Let's dive into this cosmic origin story and see if it holds up, or if it's just a beautiful dream. Picture the Big Bang, not as an explosion in space, but as the sudden emergence of space and time themselves. You're there, somehow, witnessing the universe's first gasp. A blinding flood of light and matter erupts from a single point, expanding faster than you can comprehend. It's chaotic, overwhelming, a torrent of energy that feels like the universe is screaming into existence. This is the Big Bang as we know it, a singular event 13.8 billion years ago that set everything in motion. But what if this wasn't a random burst? What if it was a white hole, a cosmic fountain pouring out the building blocks of reality from a singularity, just as a black hole swallows them? Let's set the scene. You're floating in a void that isn't quite a void, a pre-universe state where physics as you know it doesn't yet exist. Suddenly, a white hole ignites, its event horizon glowing like a cosmic beacon. Light, quarks, and raw energy stream outward, filling the emptiness with potential. Your senses reel. The light is searing, the energy a palpable hum that vibrates through you. It's not just creation, it's creation on steroids, a relentless outpouring that shapes space and time itself. You feel like you're witnessing the birth of everything, a moment so profound it makes your heart race and your mind spin. Here's a historical anchor. The Big Bang theory took shape in the 1920s when Georges Lemaitre, a Belgian priest and physicist, proposed that the universe began as a primeval atom. His idea, initially mocked as too religious, was later backed by evidence like the universe's expansion and the cosmic microwave background radiation. It is now the cornerstone of cosmology. But the notion of the Big Bang as a white hole? That's a newer twist, one that emerged as physicists explored the symmetry of Einstein's equations, which predict both black holes and their opposites. Now for a quirky fact. Some theorists suggest that if the Big Bang was a white hole, its singularity might still exist, hidden in the fabric of space-time. Imagine a cosmic fossil, a remnant of creation itself, tucked away somewhere in the universe or beyond it. It's the kind of idea that sounds absurd until you remember that black holes were once dismissed as impossible to. Let's get modern. Today's cosmologists are obsessed with the early universe, using tools like the James Webb Space Telescope to peer back at the first galaxies. Social media buzzes with images of ancient stars, sparking debates about how it all began. The white hole hypothesis fits into this frenzy, offering a radical take on the Big Bang. Instead of a random explosion, it proposes a structured event, a white hole releasing matter and light in a way that mirrors the reverse of a black hole's collapse. It's a seductive idea, especially since white holes are mathematically consistent with general relativity. But it's not without critics, who argue it's a stretch to equate a one-time event like the Big Bang with an object that might only exist in theory. Back to the sensory experience. You're still there, caught in the white hole's radiant flood. The light isn't just bright, it's primal. A raw energy that feels like it's knitting the universe together. Particles collide around you, forming the first atoms in a cosmic dance. The heat is intense, not burning but alive, like standing too close to a star being born. Your mind struggles to process the scale of it. Every galaxy, every planet, every moment of your life might trace back to this singular outburst. It's humbling, yet exhilarating, as if you're touching the heartbeat of existence itself. Here's a playful jab to lighten the mood. If black holes are the universe's ultimate shredders, white holes might be its cosmic 3D printers, churning out reality one layer at a time. But seriously, the white hole Big Bang hypothesis raises profound questions. Could our universe have emerged from the exit of a black hole in another cosmos? Some physicists, like Nikodem Popovsky, suggest that black holes in one universe could spawn new universes via white holes, each with its own Big Bang. It's a wild idea, part of the broader multiverse theory, where our cosmos is just one bubble in an infinite foam of universes. The academic debate here is electric. On one side, proponents argue that a white hole explains the Big Bang's singularity, a point of infinite density that mirrors a black hole's core. They point to the math. White holes are time-reversed black holes, so the Big Bang's expansion could be a white hole's outburst. On the other side, skeptics argue there's no evidence linking the two. The Big Bang's conditions, extreme heat, density, and quantum effects, don't neatly align with a white hole's theoretical behavior. Plus, white holes might violate thermodynamic laws, creating order from chaos in ways that don't jive with our universe's rules. Could the Big Bang have been a one-off white hole? Or is the idea just a cosmic red herring? Let's return to that cosmic scene. You're still witnessing this primordial outburst, the white hole's light fading as the universe expands around you. The chaos begins to settle, stars and galaxies taking shape in the distance. You feel a mix of awe and insignificance, like a speck in an infinite story. Yet, there's a spark of wonder, a drive to understand how this all began. Was it a white hole, a cosmic fluke, or something we haven't yet imagined? The question lingers, tugging at your curiosity like gravity itself. Let's revisit that call to action. The idea that our universe might have started as a white hole is mind-boggling. What do you think? Could the Big Bang have been a white hole's grand debut, or is it too far-fetched? Pause the video, jump into the comments, and share your thoughts. Your ideas might light up someone else's perspective on the cosmos. In the end, the white hole Big Bang hypothesis is a testament to human curiosity. It pushes us to question the origins of everything, to see the universe not as a static painting, but as a dynamic story, one that might connect black holes, white holes, and the birth of reality itself. As we pull away from this cosmic origin point, one thing is clear. The universe is full of mysteries, and we're just beginning to unravel them. You're adrift in the cosmic sea, stars scattered like diamonds across the velvet dark. Your spaceship's sensors hum, scanning for something extraordinary. A white hole, that elusive counterpart to the black holes we've come to know. Its theoretical glow promises a flood of light and matter, a beacon that should stand out against the universe's backdrop. But here's the problem. No matter how hard you look, no matter how advanced your tech, white holes remain invisible. Why haven't we spotted one? Are they hiding? Or are they just a physicist's pipe dream? Let's dive into the challenges of finding these cosmic phantoms and what it means for our understanding of the universe. Imagine pointing your telescope at the sky, searching for a white hole's radiant signature. You're expecting a dazzling outburst, a torrent of light and particles that screams, "I'm here." But the cosmos stays silent. Your screens show only stars, galaxies, and the occasional flicker of a supernova. White holes, if they exist, are masters of disguise. Unlike black holes, which we've pinned down through their gravitational effects, X-ray emissions, and even direct imaging, white holes leave no trace we can confirm. Their theoretical nature makes them slippery, predicted by equations, but absent from our observations. It's like chasing a ghost that only exists on paper. Let's set the scene. You're orbiting a distant galaxy, your eyes glued to your instruments. The universe feels alive, buzzing with energy, pulsars flashing, quasars blazing, cosmic rays zipping past. You calibrate your sensors for a white hole's telltale signs, a sudden surge of light, a stream of matter with no apparent source, or a gravitational anomaly that repels rather than attracts. But nothing. The silence is deafening, almost mocking. Your heart sinks. But there's a thrill in the hunt, a pulse of excitement that maybe, just maybe, the next signal will be the one. The vastness of space feels both daunting and electric, a reminder of how much remains unknown. Here's a historical anchor. In the 1960s, when physicist Igor Novikov first fleshed out the idea of white holes, they were seen as a natural extension of Einstein's general relativity. Black holes, once dismissed as mathematical quirks, had started gaining traction as real objects, thanks to evidence like X-ray binaries. Scientists hoped white holes might follow suit, revealing themselves through some observable phenomenon. But decades later, despite advances in telescopes and detectors, no confirmed white hole has emerged. It's a humbling lesson in how the universe guards its secrets, even from our best tools. Now, for a quirky fact, some physicists have suggested that white holes might be so short-lived they'd vanish before we could spot them. Picture a cosmic sparkler, flaring for a fraction of a second before collapsing into a black hole or dissolving entirely. It's like the universe is playing hide-and-seek, and white holes are the ultimate masters of the game, blinking out before we can yell, "Found you!" Let's bring it into the modern day. Today's astronomers wield tools like the Event Horizon Telescope, which captured the first image of a black hole's shadow in 2019, and the James Webb Space Telescope, peering back to the universe's infancy. Social media lights up with every new discovery, from distant galaxies to gravitational waves. Yet white holes remain absent from the headlines. Why? One challenge is their theoretical behavior. Unlike black holes, which reveal themselves through accretion disks or gravitational lensing, white holes might not interact with their surroundings in ways we can easily detect. Their event horizon repels matter, leaving no orbiting debris to study. They might mimic other phenomena, like gamma-ray bursts, making it hard to distinguish them without precise data. Back to the sensory experience. You're still out there, scanning the cosmos. The stars pulse like a heartbeat, each one a story of creation and destruction. Your ship hums softly, but the quiet of space presses against you, heavy with possibility. You adjust your sensors, hoping for a glitch, a spike, anything that might betray a white hole's presence. The anticipation is electric, like waiting for a storm to break. Every beep of your instruments feels like a whisper from the universe, teasing you with secrets it's not ready to share. You're a detective in a cosmic mystery, and the clues are maddeningly scarce. Here's a playful jab to lighten the mood. If black holes are the universe's drama queens, stealing the spotlight with their gravitational theatrics, white holes are like shy performers, sneaking off stage before the curtain rises. But the challenge of finding them is serious business. One theory is that white holes might have existed in the early universe, during the chaotic moments after the Big Bang, but faded as conditions stabilized. Another suggests they could be masquerading as other phenomena, perhaps a distant quasar or an unusual burst of radiation. The academic debate is lively. Some argue we haven't found white holes because they don't exist in our universe's current state, while others insist we're just not looking in the right way or at the right time. Let's dive into that debate. Detecting a white hole requires identifying something that emits light and matter without an obvious source, defying normal gravitational rules. But our telescopes are tuned for patterns we understand: accretion disks, stellar explosions, gravitational waves. A white hole's signal might be too brief or too subtle, drowned out by the universe's noise. Some physicists propose searching for anomalies in cosmic microwave background radiation or unexpected gravitational effects. Others argue that quantum processes, like the evaporation of black holes via Hawking radiation, might briefly produce white hole-like behavior. Could we have missed them because our tools aren't designed for such outliers? It's a question that fuels late-night discussions in observatories and online forums. Back to that cosmic hunt. You're still scanning, your eyes burning from staring at data streams. The universe feels like a puzzle with missing pieces, each star a clue that doesn't quite fit. Yet the search itself is exhilarating, a reminder that every discovery, black holes, pulsars, exoplanets, started with someone refusing to give up. You feel a spark of defiance, a determination to keep looking, because the universe rewards the persistent. Let's revisit that call to action. The hunt for white holes is one of cosmology's greatest challenges. Do you think they're out there, hiding in plain sight? Or are they just theoretical ghosts? Pause the video, jump into the comments, and share your take. Your ideas might inspire the next big breakthrough in how we search for these cosmic enigmas. In the end, the absence of white holes in our observations doesn't mean they're impossible. It means we need to get creative. They challenge us to rethink our tools, our assumptions, and our place in the cosmos. As we drift away from this fruitless search, one thing is clear: the universe is a master of mystery, and white holes might just be waiting for us to catch up. You're drifting through the cosmos, surrounded by a sea of stars stretching into infinity. The universe feels alive, its galaxies spinning, its energies pulsing like a cosmic heartbeat. But as you gaze into the void, a question looms. What's the end game for all this? Will the universe expand forever, fade into darkness, or collapse back on itself? And could white holes, those mysterious fountains of light and matter, play a role in shaping its ultimate fate? The idea that these theoretical opposites of black holes might influence the destiny of everything is as thrilling as it is elusive. Let's explore how white holes could fit into the grand narrative of the universe's future, or if they're merely echoes of its past. Imagine the universe as a vast stage, its story unfolding over billions of years. Right now, it's expanding, driven by a mysterious force we call dark energy, pushing galaxies apart like leaves on a swelling river. But what if white holes are part of this cosmic script? Picture a white hole blazing in some distant corner of the cosmos, spewing out matter and light. creating new structures, or even seeding new regions of space-time. Could these outbursts counteract the universe's relentless expansion? Or are they relics of a bygone era, irrelevant to the future? The question hangs in the air, as heavy and tantalizing as the gravity of a black hole. Let's set the scene. You're hovering in deep space, your spaceship a lone speck against a backdrop of swirling galaxies. In the distance, a white hole pulses. Its light cutting through the darkness like a beacon. The energy is overwhelming. Streams of particles rush past, glowing with an intensity that makes your skin tingle. It feels like creation itself, a burst of potential that could birth stars or even new pockets of reality. But as you watch, you notice the universe stretching around you, the stars growing fainter, more distant. The white hole's radiance seems fleeting, a spark in an ever-widening void. Your heart races with a mix of awe and unease. Could this be a clue to the universe's fate, or just a fleeting anomaly? Here's a historical anchor. The concept of the universe's fate has been debated since Edwin Hubble confirmed its expansion in the 1920s. His discovery that galaxies are racing apart overturned the idea of a static cosmos, forcing scientists to grapple with questions about its beginning and end. White holes entered the conversation later, in the 1960s, as physicists like Igor Novikov explored their theoretical role. Could they have shaped the early universe, or might they reappear in its twilight? The question remains open, a testament to how little we know about the cosmos's long-term plans. Now for a quirky fact. Some theorists suggest white holes could act as cosmic reset buttons, briefly reversing the flow of entropy in localized regions. Imagine a white hole popping up, spitting out ordered matter in defiance of the universe's tendency toward chaos. It's like the universe hitting rewind, if only for a moment, before resuming its march toward disorder. It's a wild idea, one that makes you wonder if white holes could be the universe's way of cheating its own rules. Let's bring it into the modern day. Cosmologists today are obsessed with the universe's fate, using tools like the Planck satellite to study the cosmic microwave background and predict its trajectory. Social media buzzes with debates about whether we're headed for a big freeze, where expansion dilutes everything into a cold, dark void, or a big crunch, where gravity pulls it all back together. White holes complicate this picture. If they exist, could they inject new matter or energy into the cosmos, altering its expansion? Some physicists speculate they might form in extreme conditions, like the final stages of black hole evaporation, creating brief bursts of creation. Others argue they're irrelevant, confined to the early universe, or purely theoretical, back to the sensory experience. You're still near that white hole, its light washing over you like a warm, relentless tide. The particles streaming past feel alive, each one a tiny seed of possibility. But as you look beyond, the universe's vastness presses in. Galaxies drift apart, their light dimming as dark energy stretches the cosmos thin. The white hole's brilliance feels defiant, a rebellion against the universe's slow fade. Your chest tightens with a mix of wonder and melancholy. This outburst of creation seems so powerful, yet so small against the cosmic tide. Could it change the universe's path, or is it just a fleeting spark? Here's a playful jab to lighten the mood. If black holes are the universe's grim reapers, white holes are like cosmic party planners, throwing confetti into the void. But seriously, the idea of white holes influencing the universe's fate is a stretch. Yet it's not impossible. Some theories suggest that if white holes are connected to black holes via wormholes, they could act as outlets for matter and energy, redistributing the universe's resources. Others propose they might have played a role in the early universe, shaping its structure before fading away. The academic debate is intense. One side argues white holes could stabilize regions of space-time, countering dark energy's push. The other insists they're too unstable or rare to matter. Could a white hole's outburst seed a new galaxy? Or is it just a cosmic footnote? Let's dive deeper into that debate. The universe's fate hinges on its density and the strength of dark energy. If white holes exist and produce significant amounts of matter, they could increase local density, slowing expansion in specific regions. But most models suggest they'd be fleeting, collapsing into black holes or dissipating quickly. Some physicists, like Lee Smolin, explore ideas where white holes could spawn new universes, each with its own fate, tying into multiverse theories. Others argue that white holes violate thermodynamic principles, making their long-term impact unlikely. It's a clash of ideas that sparks heated discussions in journals and conference halls. Back to that cosmic scene. You're still watching the white hole, its light a defiant flare in the darkening cosmos. The universe feels like a story nearing its final chapters, and you're caught between hope and uncertainty. Will white holes play a role in the ending, or are they just echoes of the beginning? The question lingers, fueling your curiosity like a star that refuses to burn out. You feel small, yet part of something vast, a witness to a drama that spans billions of years. Let's revisit that call to action. The idea that white holes could shape the universe's fate is wild. Do you think they could alter the cosmic story? Or are they just theoretical cameos? Pause the video, jump into the comments, and share your thoughts. Your ideas might inspire a new angle on this cosmic mystery. In the end, white holes challenge us to think beyond the present, to imagine a universe where creation and destruction are intertwined. Whether they're key players or minor footnotes, they remind us that the cosmos is a place of endless possibility. As we drift away from this radiant enigma, one thing is clear. The universe's fate is a story still being written, and we're all part of it. You're floating in the cosmic expanse, stars twinkling like a billion tiny questions in the dark. The universe stretches endlessly around you, a vast, mysterious puzzle that's both humbling and exhilarating. White holes, those radiant, theoretical opposites of black holes, have taken you on a wild ride, from their mathematical origins to their possible role in the Big Bang and the universe's fate. But as you hover here, bathed in the faint glow of distant galaxies, a deeper question emerges. Where do we, as curious humans, fit in this grand cosmic story? Are white holes the key to unlocking the universe's secrets? Or are they just one piece of a puzzle we're only beginning to understand? Let's wrap up this journey with a reflection on our place in the cosmos and why the search for answers keeps us reaching for the stars. Picture yourself in a quiet moment, your spaceship drifting silently through space. The universe feels alive, its galaxies swirling, its energies humming with secrets. You think about white holes, those elusive fountains of light and matter, and how they challenge everything you thought you knew. They're not just objects, they're ideas, pushing the boundaries of physics and imagination. Your heart swells with a mix of awe and curiosity, a feeling that you're part of something far bigger than yourself. It's as if the universe is whispering, keep asking, keep exploring, and you can't help but listen. Let's set the scene. You're gazing out your spaceship's window, the cosmos a breathtaking tapestry of light and shadow. A faint glow catches your eye. Maybe it's a star. Maybe it's something more. Your mind races back to white holes, their radiant mystery still lingering. The silence of space wraps around you, but it's not empty. It's heavy with possibility. You feel a tingling thrill, like you're on the verge of a discovery that could rewrite the rules of reality. Every star, every galaxy, feels like a clue in a cosmic detective story. And you're one of the sleuths, driven by a relentless need to know more. Here's a historical anchor. Centuries ago, Galileo turned his telescope to the heavens, revealing a universe far vaster than anyone imagined. His observations of Jupiter's moons in 1610 shattered the idea that Earth was the center of everything, sparking a revolution in how we see our place in the cosmos. White holes, though still theoretical, carry that same spirit of discovery. They challenge us to question the universe's rules, to imagine possibilities beyond what we can see or touch. Galileo would have loved this puzzle, scribbling notes about what a white hole's light might reveal. Now for a quirky fact. Some physicists speculate that if white holes exist, they might emit light in patterns so chaotic they'd look like cosmic static. Think of it as the universe's version of a glitchy TV signal. It's a strange idea, but it makes you wonder if we've already seen a white hole's signature and mistaken it for something else, like a distant quasar or a random burst of noise. It's the kind of quirk that keeps astronomers up at night, tweaking their telescopes for a better look. Let's bring it into the modern day. Today, the quest to understand the universe is more vibrant than ever. Social media buzzes with posts about new discoveries, exoplanets, gravitational waves, or the latest images from the James Webb Space Telescope. People share memes comparing black holes to cosmic vacuum cleaners. But white holes? They're the wild card, the mystery that hasn't gone viral yet. Scientists are pushing the boundaries, using supercomputers to simulate white holes and observatories to hunt for their faint signals. The debate rages online and in lecture halls. Are white holes real? Or are they just mathematical ghosts? The uncertainty is part of the thrill, a reminder that the universe still has plenty of surprises up its sleeve. Back to the sensory experience. You're still in your spaceship, the stars a dazzling array around you. The quiet is profound, broken only by the soft hum of your instruments. You feel small, a fleeting speck in an infinite cosmos. But that smallness is freeing. It's as if the universe is inviting you to join its story, to ask questions no one's answered yet. Your mind buzzes with possibilities. Could white holes be portals, relics of the Big Bang, or something we can't even imagine? The thought is electrifying, like a spark that lights up the dark. You're not just an observer. You're a participant in the greatest mystery of all. Here's a playful jab to lighten the mood. If black holes are the universe's grumpy gatekeepers, hoarding everything, white holes are like cosmic party hosts, flinging light and matter to anyone who'll take it. But jokes aside, white holes remind us why we explore. They're a symbol of the unknown, a challenge to keep pushing the limits of what we believe is possible. The academic debate around them is a microcosm of science itself. Some argue they are impossible, violating laws like the second law of thermodynamics, which demands increasing entropy. Others, like Carlo Rovelli, suggest they could exist fleetingly, perhaps as quantum transitions during black hole evaporation. Could white holes be the universe's way of balancing creation and destruction, or are they just a beautiful idea we've yet to prove? Let's dive into that debate. The search for white holes isn't just about finding an object. It's about testing the limits of physics. If they exist, they could rewrite our understanding of time, space, and causality. Some theories tie them to the multiverse, suggesting each black hole in our universe might spawn a white hole in another, creating new realities. Others argue they're relics of the early universe, faded long ago. The lack of evidence fuels skepticism, but it also inspires creativity, pushing scientists to design new experiments and rethink old ones. It's a debate that bridges math, philosophy, and wonder, reminding us that science thrives on questions as much as answers. back to that cosmic moment. You're still drifting, the universe unfolding around you like an infinite book. The stars seem to pulse with purpose, each one a reminder that you're part of this story. White holes, whether real or not, are a call to curiosity, a challenge to keep exploring. You feel a surge of determination, a need to chase the next clue, the next discovery. The universe is vast, but your questions make it feel alive, like a partner in a dance that's only just begun. Let's revisit that call to action. White holes are a cosmic enigma, a spark for your imagination. What do you think? Could they hold the key to understanding the universe? Or are they just a tantalizing what if? Pause the video, jump into the comments, and share your thoughts. Your ideas might light up the next big question in cosmology. In the end, white holes are more than a theoretical curiosity. They're a reminder of why we look to the stars. They challenge us to dream bigger, to question deeper, to embrace the unknown. As we drift away from this cosmic journey, one thing is clear. The universe is a story we're still writing, and every question, every wonder, keeps us turning the page.